Hello friends, welcome to this new video. So in this video, we will discuss about the Databricks Lakehouse platform. So as you are already aware about the popularity of the Databricks Lakehouse platform. So in this video, we will do a brief overview of the Databricks Lakehouse platform. So first we will look into what exactly is the meaning of a lakehouse. So first we will start with the data warehouse, then the data lake, how the data lake evolved, what makes data lake different from data warehouse. And then we will discuss what is the meaning of a data lake house. And then we will discuss Databricks data lake house. So what features we can get, how Databricks data lake house is powering big companies. So we will also discuss some use cases. So let's get started. Okay, so first let's have a brief overview of what we will cover in this video. So as you can see, and as I have already told you that first we will discuss about data warehouse. Then we will discuss about data lake. So what exactly is data lake and how data lake is different from data warehouse. So it is very important for us as a data engineer. And also we will look into difference between data warehouse and data lake. It's very interesting. Then we will jump into data lake house. What exactly is data lake house? How data lake house is different from data lake. So all those analysis we will do in this video. And then we will discuss the Databricks Lakehouse platform. So what features Databricks provide in its Lakehouse platform? What benefits you can get out of it? So all those things we will discuss. And in the last, we will discuss some case studies. So we will look into how big companies have used Databricks Lakehouse platform to do innovation. So that will be a very interesting part. So watch till the end to get full benefit of this video. Okay. So let's first start with the data warehouse. So if we look into data warehouse, so data warehouse became very popular in late 1980s. So see, in order to understand data warehouse, first let's have a very quick overview of a database. So see, we all have used database. You might know also database. So if I talk about database, so what is the idea of a database? Why we use database? So we use database to store data in a relational manner, means in the form of table. So every table will have rows and columns. So in any organization, all the transactions, all the day-to-day operations which is undergoing, so all that data gets stored in a database. Now the question is this: since we already have a database, then what is the need of a data warehouse and how data warehouse is different from a database? So this we can very easily understand from the figure. So here in the figure you can see we have different databases. So we have a database called CRM. So CRM, you know, customer relation management. So all the data related to CRM is stored in this database. So CRM is a database. Similarly, we have a billing database. So billing database contains only information about billing data. Similarly, we have ERP, enterprise resource planning database. So this particular database will be holding data related to operations, day-to-day operations, ERP operations, you can say that, and some flat files. So files, it is different from a database. So the idea is that if you take any organization and it will be having different department and it will be generating different kind of data. And we know that the best practices always suggest us that we should have independent database for different sort of data. So that gives us more flexibility. So that's why here you can see, if we look into any organization, we are having CRM database, billing database, ERP database, and also some data in the form of files. Now, see why there is a need for a data warehouse. Now the need is to basically analyze the data. If we want to analyze the data, so see, if you go into CRM, you run any SQL queries on CRM database, you can only do analysis from the aspect of CRM. If you run queries on billing database, you can do in-depth analysis of billing database, only billing database. I hope you are getting my point. So the idea is that since all the databases are independent, we need a mechanism where we can do a analysis, which we call it as consolidated analysis or combined analysis. There is a need for that. So their data warehouse plays a very important role. So see, what the idea is that you might also know it. So there is a process called ETL. So ETL is extract, transform, and load. So what it does, ETL, so first it will extract the data from different data sources. And here the data sources are relational databases. So how we will extract? Using some SQL queries. So based on the business logic, we will write SQL query. And the beauty of the SQL query will be this: those SQL query will fetch data from different sources. So basically, we are extracting the data from all the data sources, as you can see in the figure, using SQL queries and the business logic, and then we will transform the data. So after extracting the data, it might be that we need to apply some filter operations, group by operations, some transformation needs to be done. So that also is done using SQL. Then we have to load the data into the data warehouse. Now, what this data warehouse is, data warehouse basically contains data mart. Now, what is this data mart? Data mart is also a database. So data mart are also database, and this database will have a particular schema based on the scenario or the business logic. So see, if I talk about data warehouse is collection of data marts, and data marts are itself databases. So data warehouse is also a collection of database where every database will have a particular schema. Every database will follow a particular schema. So this is the idea. Now, and definitely the schema will be such that it will support combined analytics. So the now the idea will be, we will extract the data from independent data sources, which will do some transformations, and we will load that data into data marts. And then, so what benefit we will get? We can do analytics. So we can do reporting. So while reporting, now we will be running queries on data marts, because we know that okay, data mart is containing consolidated data, and we can perform analytics and we can perform data mining. So definitely data warehouse played a very important role in doing some data analysis. So the idea is this: big companies, they are generating lots of data, they are having lots of historic data. There was a need arise where the engineers thought that okay, let's try to decode some useful insights from the data. So that's why they prepared an architecture like this, and using the data marts, they definitely did some great analysis which helped the company in decision making, taking some decisions which definitely uh, might be very fruitful for the companies. So in the so this is a very traditional way which is being done in all the big companies. So data warehouse is very popular. It is being used all across the globe. So I hope you got a very in-depth understanding of how a data warehouse works. Now the next point is, okay, so this is very clear to us. Data warehouse is very powerful. It helps in doing a consolidated analysis. But what are the drawbacks of data warehouse? Because the drawback of data warehouse led to the emergence of data lake, because data lake is the next big thing after data warehouse. So data warehouse does not support big data analytics. This is very important. Data warehouse does not support big data analytics. Now if I talk about big data, so I should remember 3V: variety, velocity, and volume. A data with variety. If I talk about variety, means it is not just structured data, it can be unstructured data also, and semi-structured data also. Now let's try to understand what is the meaning of this. Structured data, we know that, okay, all the data present in relational database is structured because it is following a structure of rows and columns. In the flat file also, we can have a structured data. But if I talk about images, so image is also having some data, so that is unstructured. All the data which is emerging from social media, all those data, because it is not having any specific format, means any structure. Or if you are aware about Internet of Things, those sensors are also generating data. So sensors are sensing the environment and they are pushing that data into the cloud. So all those real-time data is also highly unstructured. So basically, definitely data, it is not necessary that data should always be structured. Data can be unstructured also. So big data means all kind of data, whether it is structured or unstructured. So that is variety. And if I talk about big data, I talk about velocity, means real-time data, real-time streaming data. See, here in relational databases, all the data is not real time, it is stored. So it is stored and then we do analytics on it. But there are streaming data. Let us suppose you are watching this video. So this video is being streamed. It is buffered and it is streamed. So all that streaming data is real time data, data which is coming from sensors. All those are real time data. So that is a big data. So big data is having variety, velocity, and volume. Volume is huge data, petabytes of data. So big data satisfies these three very important characteristics, that is variety, velocity, and volume. And unfortunately, the current architecture of the data warehouse which we are discussing, it does not support these three aspects, because data warehouse only supports structured data. Data warehouse only supports stored data. It does not support real-time data. And there is a limitation in memory also, because if you perform SQL queries on petabytes of data, it will take months to get to the result. Because you know, na, see, SQL also, it will be doing some searching, sorting operations. So if the data is huge, so it will take lots of time. So there it gets failed. So this architecture has a limitation. The limitation is that it does not support big data analytics. And we are in an era where big data is shaping the world. All the big companies are transforming into big data analytics. So definitely we need a mechanism to handle big data, and then undergo big data analytics. So there, that data lake plays a very important role. So now let's look into the data lake. So data lake emerged in the year 2011. So it became very popular. So let me show you the architecture of data lake. So as you can see in the figure, we have a data lake. So we start from the bottom. From here we will start. So see, these are all data sources. So we have image, we have videos, we have audio, we have file, we have databases. So the idea is that in data lake, we can ingest all kind of data. In data warehouse, we were only able to ingest structured data, but in data lake, you can ingest all kind of data, whether it is structured, whether it is semi-structured, or whether it is unstructured. All kinds of data we can ingest inside the data lake. So this is a very interesting feature. And see now how it is done. See, so the idea is that inside the data lake, it follows a particular format, and the most popular format is Parquet. You might have heard about it. So there are Parquet files. So the idea is that whatever data we are ingesting inside the data lake, data gets stored in the form of Parquet files. So Parquet, the beauty of Parquet file is that uh, any kind of data, whether structured, unstructured, semi-structured, you can convert it into Parquet format. And data lake contains lots of Parquet file. And also data lake, there is no limitation to size. Petabytes of data also you can store in the form of Parquet file. And then using this data lake, so this is the data lake. As an see lake, data lake as a we can easily understand. Okay, it is the lake of data. So here the data is stored in the form of Parquet file, and this lake we can see the lake. So here it is the data lake. It is containing all the data. Now using ETL on this data lake, we can do magical big data analytics. So here ETL, we have already discussed extract, transform, and load. Now we will extract the data from the data lake. We will do some transformation, and we can load it in different data sources. Let us suppose we can load, now we can load this kind of data into data mart to perform some kind of business intelligence or reports, or we can directly load the data into some real-time databases. We can also undergo machine learning. We can prepare machine learning model directly from this data using ETL. So see, ETL is very important. ETL is an interface between your application and the data lake. So let us suppose you want to do machine learning. You will be writing code, and definitely in machine learning, you know that you have to train a model. So you need a training data. So what you will do in the code, you will just use the ETL to ingest the training data from the data lake into your machine learning model. So ETL plays a very important role, and this is a very important architecture of data lake. So now I hope you got an idea, okay, how you can use a data lake and how exactly the data lake works basically. So this is very clear to us. And if I talk about big data analytics, so now we are very clear that, okay, data lake supports big data analytics. So in data lake, we can have variety of data, and also we can have real-time data also. So here the data source can be any sensor also, which is ingesting the data in real time, and that data will get uh, via data lake. It can be ingested, and via ETL it can be ingested into the ML model. So this is the beauty, or in any other application. So what I'm trying to say is that, let us suppose a sensor is generating a data at any particular rate, like 100 Mbps or 100 megabytes per minute, for example. So that data can first it will get into data lake, and automatically it will, using ETL, it can be sent to any application where it can be processed and some results can be generated. So real-time analytics can be done using data lake, and also volume, petabytes of data, we have seen it. So if I talk about big data analytics, four very important aspects it covers in terms of analytics. So streaming analytics means real-time streaming, which we have seen. Data science, very popular. Business intelligence and machine learning. So hence data lake became very popular, and all the, in the current scenario, companies have shifted to data lake. From warehouse they have shifted to data lake, and hence proper and clear understanding of data lake is very important for you. Yeah. Now let's very quickly look into the difference between a data warehouse and a data lake. The difference is very obvious to us. So just very quickly look into it. If I talk about data warehouse, the data will be refined. It will only be structured. The data will be smaller and it will be relational data. But if I talk about data lake, it will be raw data. It can be any data, structured, unstructured, semi-structured, real-time data. All the data is being supported, large data and undefined data. Unstructured data is a sort of undefined data. So this is the difference, basic difference between a data warehouse and a data lake. And hence data lake supports more data. No? It is very clear to us. So definitely data lake is the big thing and it is being used. So it is replacing data warehouses because in data lake architecture, you can implement data warehouse very easily. As you have seen here, we have data mart. So collection of data mart is a data warehouse. So data lake in itself, it is containing a data warehouse. So now this is very clear to us. Now let's jump into data lakehouse. So just now we covered data lake. Now we are covering data lakehouse. And data lakehouse became popular in 2020, in the year 2020. Okay, so let's try to understand data lakehouse, its architecture, and how lakehouse is different from lake. How data lakehouse is different from data lake, that also we will discuss. So first, let's quickly try to understand its architecture. So as you can see in the left hand side, so I am marking it. So here we have different format of data. We have structured data, we have textual data, we have other unstructured data. Okay. Now what we are doing, so we have here ETL. So we have different type of ETL. So this is the textual ETL for textual data. And for structured data, we are having a sort of ETL. And using some APIs and some ingestion mechanism. Basically, this is the data lake. This area, the disk-like structure which you are seeing. This raw data in open file format. So open file format is also very clear to you. So the beauty of open file format is that any kind of data can be converted into open file format, and one of the very popular open file format is Parquet files. So see here also we are basically ingesting the data into the data lake, the open data in open file format. Now how lakehouse is different, and also we are doing some analytics. So until now the picture is same, means what we did in data lake also we are doing the same thing. From the data sources we are ingesting the data into the data lake, and from data lake we are basically pipelining it into different sources where we are doing the analytics. Here also we are doing the same thing, but the difference is here in the data lake we have one more layer of functionality which is enhancing the data. So here you can say curated data with governance. So if I talk about governance, I am talking about some standards. So now the idea, see in data lake, the data is being stored in Parquet file, that's it. And nothing else is done. But in data lake house, we are following some open standards also. And also this data lake house, it supports atomicity of transactions and many more features. So the idea is that if I talk about data lakehouse enhances the data, the quality of data or accessibility of data, like atomic transaction it supports. Now, what is the meaning of atomic transaction? That also we will see. And before that, one more very interesting difference we have to see. Data lakehouse is a collection of data lake. In the right hand side, you can see, you will get more clear understanding what I'm trying to say, the difference. So if I talk about data lakehouse, so data lakehouse is a collection of data lake. It means we can have separate data lakes into inside one lake house, and definitely we can write some APIs over the data lakes, and using this APIs directly our applications can do analytics. So this is very clear to us. So until now what we have seen is that inside data lakes there can be many inside data lake house there can be many data lake. Inside data lake house there can be many data lake, and also data lake house follows some open standards. So data house follows some open standards, and also we can write APIs for operations. And one more very important difference we have seen, that is the atomicity of transactions, atomic transaction. So atomic transaction, you are very you are, I think, I hope you are aware about that. If I talk about atomic transactions, so the property of atomic transaction is that transaction gets committed only if it is being completed. Let us suppose a transaction get halts in the middle. If the transaction due to any reason, then it will not get committed. So data lake does not follow atomicity. It means that let us suppose you are ingesting the data inside data lake, and there are 5 operations in a transaction, only 2 gets committed. After 2 operations, so because of some reason it gets interrupted or it gets terminated, then only that 2 operation will be committed, rest 3 will not be committed, and hence inconsistency will be created in data lake. But in data lake house, this feature is an inbuilt mechanism. So the idea is that if a transaction contains 5 operations, and if due to any reason 5 operations are not able to complete, transaction will not get committed, it will undo itself. So this is very clear to us. And in data lake you have to implement atomicity separately. You have to write the code for that, you have to manage that aspect separately, and many more aspects like that. So in short, we are convinced that okay, data lake house is the advanced version of data lake with many more enhanced features like atomicity and many more. So that's why data lake house is the choice which the company is preferring over data lake. So data lakehouse is the advanced version of data lake, we can say that, and data lakehouse is a collection of data lake. So now we got a good understanding of data lakehouse also. Now let's move forward. Okay. Now we will look into the Databricks Lakehouse platform. So Databricks, you know, it's a company. So Databricks implemented its own Lakehouse platform. The similar architecture, the Databricks company implemented the Lakehouse, and the name of that Lakehouse is Databricks Lakehouse platform. So now whenever you hear Databricks Lakehouse platform, you get an idea, okay, what it means. It means it is a lakehouse. And we know that, okay, if I talk about lakehouse unifies data warehousing and AI use cases in a single platform. So in a single platform, we have all kind of data in open file format, and we can have a data warehouse also, and ML AI data science also. This we have already seen, and in this figure also we can see this. So if I talk about Databricks Lakehouse platform, it is simple, open, and collaborative. This we will look into detail very soon. And it supports data engineering, business intelligence and SQL analytics, real-time data applications, data science, and machine learning. Now see how the similar architecture is been implemented by Databricks Lakehouse platform. As you can see, let us start from the bottom. In the bottom, we can see structured data, we can see semi-structured data, we can see unstructured data, and we can see streaming data. It is being ingested into the open data lake. So this is the open data lake, and the open file format is Parquet. So Databricks is following Parquet open file format. So whatever the data is getting stored in the data lake, it is being stored in the form of Parquet file format. And one more very interesting thing that the Databricks platform has, that is the Delta Lake. So Delta Lake gives us features like atomicity and data management and governance, like open standards and all that stuff. So that is being achieved by Delta Lake in Databricks. So Databricks uses Parquet file format, Databricks uses Delta Lake. So using this data, we can perform analytics. We can do business intelligence, SQL analytics. We can do some sort of data engineering, some sort of real data applications we can make. We can also do data science and machine learning. So this is the beauty of Databricks Lakehouse platform. I hope you got a very clear picture of Databricks Lakehouse platform. And also one more very interesting feature of Databricks Lakehouse platform is that it also supports data ingestion directly via cloud. So it supports Google Cloud, it supports Azure, it supports AWS. So you can have Databricks inside Google Cloud. We have Databricks inside Azure. We have Databricks inside AWS. So let us suppose you are using AWS cloud services, Amazon Web Services, and there is an option of Databricks services also. You can subscribe to that, and you can use Databricks on top of AWS. So now the data store can be your AWS also. Means you can use all the services of AWS along with the Databricks architecture, the data lakehouse. Similarly, Azure with Databricks and Google Cloud with Databricks. So this makes Databricks more powerful, because see, all the big companies, tech giants, they are already using any cloud. Means definitely they are using some sort of cloud. Either they are using Google Cloud, Azure, or AWS. Now they got an advantage. Let us suppose they are using Azure, Microsoft Azure. Now they get an important advantage. Okay, let us use Databricks on Azure. So their operations will also not get disturbed, and they can directly ingest, they can connect Databricks with Azure. So this flexibility also we get. Yeah. So yeah, this is very clear to us. Let's quickly look into this also. Here we can see we have different cloud. So we call it as cloud data lake. So cloud data lake means data lake on cloud. That is cloud data lake. It means the data lake is on cloud. You can access that data lake from any part of the world, because it is on cloud. You can access it on any device. And cloud data lake will contain all the structured and unstructured data, and we can ingest data into the cloud data lake via different sources that we have already seen. So now here the data store, because see, in order to implement a data lake, you also need a data store, not data storage facility. So here the cloud will be the data store. It will be storing the data in open file format, that is the Parquet files. It will be storing the Parquet files. Then we have the Delta Lake, which we have already seen. So Delta Lake basically gives us data reliability and performance. Then we have Unity Catalog. This is very important. So this is for governance, data governance. So it is basically for implementing some open standards which are used worldwide. Unity Catalog. And on top of it, so we can use this data as a data warehouse in data engineering, in data streaming, and in data science and machine learning. So this is, now we are very familiar with the Databricks Lakehouse platform, its architecture. And if I quickly talk about its features, so we know that, okay, it's the Databricks Lakehouse platform. It supports data engineering, analytics, business intelligence, data science, and machine learning support. We have already seen. It delivers the reliability, strong governance, openness, flexibility, and performance of data warehouses. it's built on open source and open standards to maximize flexibility. So that's why it's open. See, it's simple because we have seen its architecture is so simple to understand, so easy to understand. And see, we will be getting this architecture already implemented. We just have to use it. And in order to use it, you just have to ingest the data into the data lake and do some configuration in the data lake and start writing your applications. So as a data analyst or a data, because see, as a data scientist or a data analyst, our primary goal is to get insights from the data and not get stuck in managing the data. So Databricks do all the management stuff. And also it is open source and it follows open standards. Its common approach to data management, security, and governance helps you operate more efficiently and innovate faster. This is very clear to us. Now, I hope we got a very good understanding of it. Yeah. So we have already seen, if I talk about Databricks Lakehouse platform, it is simple. So we can eliminate all the complexity and expenses because everything is there in the architecture itself. So as a user, let us suppose you want to go for AWS, you just uh, subscribe to Databricks on AWS service. That's it. And you will get the entire architecture already implemented. Using some writing some code, you can ingest all your data into Parquet file format, and then you can directly do analytics on that data. It's so easy. So that's why it's very simple. It eliminates all the complexity and additional expenses. Now, no need to additionally implement any data lake or any data governance. Everything you will get inside Databricks, and you can achieve the full potential. Definitely, you can devote most of your time in analytics and AI initiatives rather than getting stuck in data management activities. And also, if I talk about this Databricks Lakehouse platform, it is open. We have already seen. So it is open source. So basically, three main open source initiatives, they have implemented the Databricks Lakehouse platform. We have this Apache Spark, MLflow, and Data Lake. So these three are the part of Databricks Lakehouse platform. So the Databricks Lakehouse platform contain Apache Spark. So you know that Apache Spark is 50 times faster than a traditional database. In Apache Spark, you can run queries just like you run in any traditional database. SQL queries. SQL query you can run. And the beauty of Spark is that it is 50 times faster. It's very interesting. And also MLflow is for machine learning models, and Delta Lake we have already seen. So it is open source. And multi-cloud we have already seen. Databricks supports Microsoft Azure, Google Cloud, and AWS. So it is consistent management, security, and governance experience across all the clouds. Means we can, the interesting part is that we can also use features of that cloud along with Databricks. Let us suppose you are using Databricks on Google Cloud. So Google Cloud has got a very interesting feature of BigQuery and lookups. So all those things you can integrate. Google Cloud has got its own AI, Google AI. So that also you can use with Databricks to take your analytics or whatever problem you are solving, that you can solve in a very innovative manner. So you don't need to invest in reinventing processes for every cloud platform. Yeah. So whatever cloud platform you are using, the most popular one, you will have Databricks for that. So that's why it's very interesting. Yeah. So now we have covered all the insights. We have analyzed in great detail what is this Databricks Lakehouse platform. Now we will be discussing some case studies, means of companies how they have used Databricks Lakehouse platform so to innovate their business operations. So if I talk about HSBC, so reinventing mobile banking with machine learning. So HSBC manages cashless transactions for over 39 million customers with machine learning based fraud detection. So see, cashless transaction, we know that it is basically digital transaction, and digital transaction for 39 million customers. Just look at the number. So it will be a streaming data, and HSBC has used Databricks Lakehouse platform to implement machine learning based fraud detection model on this data set, and they have successfully achieved that. So now definitely HSBC has got a feature where if anybody tries to do any kind of fraud activity by digital payment, it can basically detect that using its ML based fraud detection. And this particular system is being implemented in Databricks Lakehouse platform. So definitely first they are ingesting the data in the open data lake, that is the Parquet file format. Then definitely they will be implementing their machine learning models, and in this way they have achieved their goal. Similarly, we have Starbucks, so bringing data and AI at scale. So Starbucks serves up omni-channel experience across 30,000 stores with Databricks. So we know that Starbucks is an international brand. It has its visibility all across the globe. So more than 30,000 stores across 30,000 stores. So see, every store is generating a data. It is very clear to us. Every store, because day-to-day activity is going on in the store. Attendance management will be there, payroll management will be there, and also inventory management, order management, billing management. So many management will be done, and all that data is getting stored. Now Starbucks is using Databricks to ingest all that data so that they can also manage their day-to-day operations along with analytics. And analytics will help Starbucks in decision making. Which store is performing good, which store is not performing well. They might need some marketing activities or some other kind of innovation to increase the sale. What is the response time? Means let us suppose the counter received an order, at after how much time the order is delivered to the table, all that kind of stuff. Star performers, for example, all that kind of analytics can be done very easily using Databricks. So Starbucks is already doing that. And also we have the future of entertainment with AI. So the artificial intelligence in entertainment industry. So Comcast delivers an Emmy-winning viewer experience with AI-powered voice remotes. So basically, Comcast is using artificial intelligence in the field of entertainment, and definitely whatever the data is being generated, the entertainment data that is being managed in the Databricks Lakehouse platform, and some AI stuff is being developed by Comcast. And we have artificial intelligence is transforming drug discovery. So AstraZeneca is very popular after COVID-19. It became more popular. So drug discovery, you might know that if we encounter any new disease, so we have to discover a drug for that. Just like for COVID-19, we saw it took long to discover the vaccine for COVID-19, because COVID-19 was a novel coronavirus. Novel means unique. We saw it first time. So AstraZeneca leverages data and NLP to help scientists research novel drugs. So now, what is the importance of natural language processing, NLP? So we know that, okay, if I talk about drug discovery, it is a sort of we can call it like genetics. So in genetics, in genetics we have seen this ATG. So a combination like this. So we have gene codes. So we have to process that. So we can process it using natural language processing. So the idea is that AstraZeneca also, whatever data they had, they just ingested it into the Databricks Lakehouse platform, and using that, they did some analytics, and they were able to optimize their drug discovery time. Yeah. Yes, so this was about today's video. So I hope you liked it. You got a very clear understanding of the Databricks Lakehouse platform. What is a data warehouse? What is a data lake? What is the difference between a data warehouse and a data lake? And also how data lake house is different from a data lake. What are the features of Databricks data lakehouse platform, and some interesting use cases we have studied. So please like this video, comment on it, share it in your circle, subscribe to my YouTube channel. You will get lots of interesting videos like this. So thanks for watching. Thanks for your time.